Now let us suppose this is my question. I have been asked to find the maximum flow from this particular source to the destination, okay, for this particular transport network. So for maximum flow I need to find the min cut, for which I have just seen the algorithm. So let us see how we are going to proceed. My first step would be to give a flow of 0 to all the edges. Okay, so let me do that first. Let me just paste it over here. Okay, and over here I am going to give a flow of 0. So let us suppose I give a 0 over here, I give a 0 over here, 0, 0, 0, 0, 0 and 0. Okay, now I have given a flow of 0 to all the edges. So the next step is I have to start labeling. Okay, so let me start labeling. My S is always dash comma infinity. Okay, now I have to look for the vertex which are adjacent to S. So let us start with B. Okay, B is adjacent to S. So what it is going to be? It is going to be S plus comma delta B. Okay, what is delta B? Delta B is equal to the capacity of edge from S to B minus the flow of edge from S to B. So over here the capacity is 2 and flow is 0. So 2 minus 0 is 2. So your B is going to be S plus comma 2. Okay, similarly another adjacent vertex which I have over here is, let us call this as C. Okay, so now I can label my C like this. It is going to be S plus comma delta C. And what is delta C? My delta C is going to be, the capacity is 9 and the flow is 0. Okay, so it is going to be like this. Do we have one more adjacent vertex? Yes, I have D which is adjacent to S. So D is going to be S plus comma, the capacity is 3 and flow is 0. So delta D is going to be 3. Okay, so this was what? This was my step number, where am I? This was my step number 2. Okay, now my step 3 says for all the vertices adjacent to a label vertex I have to start labeling. So at this moment I have 4 vertices which are labeled. So let us find out other adjacent vertex which are adjacent to a labeled vertex. So I think T in itself, I can directly go to T, right? Because it is adjacent to D and D is labeled, right? So your T can be labeled like this. T is going to be D plus, since we are coming from D, comma delta T. And what is delta T over here? Delta T is minimum of, delta T is minimum of delta D comma capacity minus flow, which is 5 minus 0. Okay, so what is my delta D? My delta D is 3, right? So over here I am going to give delta T is equal to minimum of 3 comma 5. So it is going to be 3. So T is D plus comma 3. Okay, D plus comma 3, right? So as per my algorithm it says that repeat the steps until the sink is labeled. Okay, so my sink is labeled at this point. So after that what I need to do is I need to find the path from source to sink. Okay, I need to backtrack from sink to source. Okay, and give a flow of delta T to every edge in the path. So what is my path? From T I go back to D, from D I go back to S. Okay, so my path is like this.